Today in this video, we will study about corona effect in a transmission line. We will know what is corona effect, why this phenomena occurs, what are the factors which affect the corona, what are the advantages and what are the disadvantages of corona, how to calculate the corona loss for a transmission line. First of all, what is corona? So, in case of a transmission line, sometimes we observe sparking, and due to this sparking, there will be some hissing noise there, and there will be some violet glow. So this complete phenomena is called corona effect in the transmission line. Now, why this happens? So, for example, in a transmission line, when a high voltage is produced, when a high voltage is provided, then if the line is charged, then what will happen? The surrounding air will also get ionized. Why? Because due to the conductor is charged, so there will be some field which will generate surrounding to this conductor. So the surrounding air will also get ionized, and due to this ionized, there will be some charged particles. Already in the conductor, some electrons are present there. So these electrons will come towards this ionized air. So the electron will come towards these particles. So there will be collision of electrons and charged particles. Due to this collision, some sparking will occur. Some sparking will occur, some hissing noise and violet glow will be there. So that's why due to this ionizing of air, there will be corona. That is the reason why corona occurs in the transmission line. Now, there is a term which is known as critical disruptive voltage, which is if it is more than 30 kilovolt, in that case, corona loss will occur. This is the standard value. Now, what are the factors on which the corona depends? First one is if there is a rough surface of this conductor like this. So if this is a rough surface, the chance of corona will be higher. Chance of corona loss PL will be higher. Second one is it depends upon the atmospheric condition. For example, if this is a conductor and it is a rainy season, then there will be some moisture in the air. There will be more moisture in the air as compared to the summer season. So in the rainy season, the chances of ionization through the air will be more. So due to this humid weather, there will be high chance of corona. Third one is spacing between two conductors. If this is a transmission tower, then these are two conductors, 1, 2. And if this spacing is low, then due to this conductor, there will be some field. Due to this conductor, there will be some field also. And if the spacing is low, in this case, there will be high chance of ionization in the air. So if the spacing is low, then there will be more corona loss. So these are some factors on which the corona effect depends. Now, we will understand about some disadvantages of corona. First one is it reduces the life of conductor. For example, if corona occurs in the transmission line, so some ozone gas will produce there. Due to this O3 gas present, there will be some corrosion in the conductors of transmission line. So due to this corrosion, life will get reduced. Second one is power loss will be there. In a transmission line, if there is corona, some power will lose here. So the sending end voltage, if sending is power is P, then the receiving end power will be lesser than P because some loss will be there. Now there are some advantages also. First one is it reduces the transient effect to the transmission line. For example, if the corona occurs in this transmission line and if suddenly a surge comes to this line. Then the excess current, then the excess power will transfer to the corona loss. The excess power will transfer in the form of corona loss. So the effect on this line will be lesser of this surge. So in case of sudden unbalancing, the unbalanced part will be converted towards in form of corona. So it will protect the transmission line. Second one is it will increase the current carrying capacity of the conductor. For example, if this is a conductor and if this corona occurs, then the surrounding air will also get ionized. And due to this ionized, it will be virtual conductor. If this is a actual conductor, then due to this ionization, due to this air, it will be virtual conductor. So the diameter of this conductor will increase. Since the diameter will increase, the current carrying capacity will also increase. So in case of a sudden arising of current, it will not hamper to our conductor. It will have more capacity to carry the current because of this corona effect. So these are some basic advantages of corona. Now we will understand about the factors by which the corona effect can be reduced. But to understand about the factors, we will first understand the formula of corona loss. From this formula, we will understand the factors one by one. So corona loss is equal to 242.2 multiply 1 f plus 25 upon del under root of r by d v minus vc whole square into 10 power minus 5. And the unit is kilowatt per kilometer per phase, where del is air density factor. This f is frequency of the line. This r is radius of the conductor, and the d, small d, which is spacing between the conductors, spacing between two conductors. This v, which is voltage level of the transmission line, and this vc, which is critical disruptive voltage. From these values, we can easily calculate PL. Now we will understand on what factors corona depends and how can we reduce the corona loss. First one is, if we look at this formula carefully, we will find PL. Power loss is directly proportional to F plus 25. So if frequency of the power, if frequency of the line will reduce, then the power loss will also get reduced. So to reduce the corona, frequency can be reduced. This is first result. Second result is if D. If we look carefully, then PL is inversely proportional to this D, because D is in denominator. P, if D will be increased, PL will be PL will reduce. D is spacing. If the spacing between two conductors will will increased. If the spacing between two conductors will be increased, corona will corona loss will decrease. As we understood earlier, if this is a transmission line, conductor 1, conductor 2, this will be more. If this will be more, then loss will be lesser. Now the third one is power loss is directly proportional to V minus Vc whole square. This came from here. So if the value of V minus Vc will be lesser, then power loss will be lesser. And if we have to bring down this value, then we have to increase Vc. Vc will be more, V minus Vc will be lesser, and the power loss will also be lesser. The corona loss will be lesser. And we know that Vc is critical disruptive voltage. The formula of Vc is mgr del ln d by r. In this case, Vc directly depends on the radius of conductor. So If we have to increase the VC, then we have to increase the radius of the conductor. So since the radius of the conductor will increase, VC will also get increased. So V minus VC will be lesser, the corona loss will be lesser. So third result is R should be higher. So we can use bundled conductor. If this is a conductor, then we can use some bundled conductor. In this case, the effective R, effective radius of this conductor will be increased. From this, PL will be lesser. Power loss or the corona loss will be lesser. So these are some factors on which the corona depends.